Hey folks, and welcome back. Hope you all are doing well. Welcome to lesson number 2 from unit number 4. Today we're going to be talking about how do we write the formulas for ionic compounds. And so last time we talked about how there were both covalent bonds and ionic bonds, forming molecular compounds and ionic compounds. Today we're going to be focusing on just the ionic compounds and how do we write formulas for those ionic compounds. So let's hop right into it. Just a quick recap. Remember that the ionic compounds are compounds that are formed when a metal gives an electron to a nonmetal, and that this transfer of electrons creates a positive and negative ion that attract to each other. And this is going to be important when we come up with our ionic compound formulas. Now, before we can actually talk about what ionic compound formulas are, we need to talk about chemical formulas, right? We haven't really talked about those yet. Chemical formulas are a representation of the number of different elements in a compound or molecule. All right, and there are two main things that we need to take a look at. Okay, the first are the subscripts. Okay, subscripts are these numbers here. They're the small numbers that come after the element name. Okay, so those are the subscripts. The subscripts tell you how many of that element there are, and that's the number, the element in front of the number. So this 2 in H2O is telling you that there are 2 hydrogens, not that there are 2 oxygens. Okay. Here, the Al2 is telling you that there are 2 aluminums. O3, that's telling you that there are 3 oxygens. Okay. Now, we also have another number, right? These are the coefficients. The coefficients are the large numbers out in front of the entire formula, okay? And that's telling you how many of all of them you have. So the way that we would handle this, okay, if we wanted to determine how many of each element there were for each, what we would do is we would say, okay, I have O2, O. Now you'll notice that there's no number there. That number doesn't mean that there's a 0 there. We assume that there's a 1, okay? So this is H2O1. We just don't write ones. So that means that there are 2 hydrogens, okay? And there is 1 oxygen in H2O. That's what this is telling us. For the second one, we have 2 Al2O3. Now, the 2 is telling you that we have 2 of everything that comes after it. Really, you can think about this as kind of like in math when you have parentheses, right? The 2 is going to multiply across everything. So Al2, right? We have 2 aluminums, but we also have a 2 out in front, so it's really 4. So this is telling us that we have 4 aluminums, okay? And we have 6 oxygens. 2 times 3 is 6, okay? So that's what these chemical formulas work. We're not going to spend a lot of time right now worrying about counting up the number of atoms in these formulas, but in the future, when we balance chemical equations, we're going to need to be able to read these formulas. All right, so here's just some more examples. You can see that we can get some parentheses involved with a subscript, right? And that's okay. I just want us to kind of start to get a feel for what these chemical formulas look like. Okay, so now let's get into the nitty-gritty of what we're doing today. How do we write the formula for an ionic compound if all I do is give you the name of the compound, right? That sounds really daunting. It's not too bad, okay? The first thing we need to do is we need to write the symbols for the elements in the same order that they are given in the name. So here is our example. We have barium chloride. Now you'll notice that we have an IDE ending here. The IDE ending is something that we add for the names of compounds. Chloride is not something you would find on the periodic table. However, you would find chlorine. So you will need to go to your periodic table to figure out what the symbols are. So we'll go ahead and do that. Here's our periodic table, right? Barium over here on the left, that's Ba. Okay, so there's Ba. And then chlorine over here on the right, Cl. All right, so we're going to write in the symbols Ba and Cl. Okay, so that's the first thing. Now, we're not done yet because we need to determine whether or not we need to add any subscripts. Okay, we're not going to be adding any coefficients here, but we do need to figure out if we're adding any subscripts. All right, So let's figure that out. It says we need to add the oxidation numbers for each of them. So we need to go back to our periodic table and look and see what are the oxidation numbers. Remember, those oxidation numbers are the charges that the elements in the A group have when they become stable. And when we're forming compounds, all of them are getting stable, so we need to know and use the oxidation numbers. So remember, this is the pattern: +1, +2, +3, plus or minus 4, -3, -2, -1, and then 0. All right, so barium is right here. Okay, it's in group 2. It's got a +2 oxidation number. So we need to come back and write in +2. Chlorine, all the way over here on the right, is in group 7A. It's got a -1 oxidation number. So -1. Okay, so we added the oxidation numbers. That was step number 2. Step number 3, we need to cross the oxidation numbers to become subscripts. So we're going to take these and we're going to cross them. They go to the other element. All right, so I'm going to rewrite this to hopefully make it a little easier to see. So now we have Ba, and the subscript is going to come down. So this is a 1. And we have Cl with a 2. Now you'll notice that I didn't write the charges, okay? So we don't need to write the charges. We just write the number itself. So this is Ba1Cl2. Step 4, we reduce the numbers that can be divided by a common factor. In this case, we can't do that. And we drop any 1s, so we don't need the 1. So I'll erase that. And so our answer is going to be BaCl2. This is our formula for barium chloride, okay, BaCl2. Again, we crossed the oxidation numbers, we dropped the 1s, and this is our final answer, okay? So what we're going to do is we're going to do a couple more examples together, and then we will move into, and then you're going to do the rest of the practice on your own. So our next one here, we've got boron nitride. Again, the IDE endings you're not going to find on the periodic table, but you will be able to find elements that sound very similar. So that's not what I wanted to do. That's okay. I'll just rewrite this real quick. +1, +2, +3, plus or minus 4, -3, -2, -1. Okay, so we're looking for, what was it again? Boron nitride. So we're looking for boron. Okay, so here is boron, and we're looking for nitride. That's going to be nitrogen. Okay, nitrogen. So boron is B, nitrogen is N. So we've got B and N. All right, we need their oxidation numbers. Boron +3, nitrogen -3. So +3, -3. All right, we'll rewrite it down below. We've got boron, and then we've got nitrogen. We're going to cross the subscripts. I'm sorry, the oxidation numbers. All right, so this is going to be B3N3. And again, here, right, we want to reduce them. So because we can divide both of these by 3, right, this is actually just going to be Bn. So because we can divide them both by the same number, in this case 3, that's going to leave us with just Bn, and that's going to be our answer for that one. Okay? All right, next one, next example, sodium oxide. Let's erase this. Okay, sodium oxide. So where's sodium on the periodic table? Sodium's over here on the left. And then oxide, that is going to be oxygen. So over here on the right. So NaO. So we have Na and O. All right, let's look on the periodic table. Oxidation number for sodium, +1. Oxidation number for oxygen, -2. So this is going to be +1, -2. We're going to cross this. And so that's going to become Na2O1. Remember, we dropped the ones, and so the final answer is Na2O, and that is sodium oxide. All right, we'll do one more example together. Beryllium carbide. So we got to look at our periodic table. Got to find beryllium. Looking for beryllium. Okay, so beryllium is over here on the left-hand side of the periodic table. So there's beryllium, and then carbide is going to be carbon. So we've got beryllium and carbon. So that is going to be Be and C. So we have Be and C. Be has an oxidation number of +2. Carbon has an oxidation number of plus or minus 4. In this case, we'll go with minus because this is an ionic compound, so it's going to be opposite of the other one, right? Because remember, in ionic compounds, you have a metal and a non-metal that are being attracted. So this is Be +2, carbon -4. Remember, our next step is that we're going to be crossing these. Okay, so this is now going to become Be4C2. Now again, we want to look and see if we can reduce, and in this case we can. Both of these are divisible by 2, and so this is going to be Be2C1, but we don't need the ones, right? So this is just going to be Be2C, and there is our final answer for beryllium carbide. All right. So make sure that you open up your notes, that you finish taking the notes that you need to. Make sure that you write your summary, and then make sure that you go through and you practice writing your formulas for the ionic compounds. Okay. So go through and answer all of these. Do your practice. Hit that save button and make sure that you submit it. And I hope that I will see you soon.